Hello folks, this is 2022 October November paper 1-2 and the question number is 17. This question is concerned with the chapter pressure and density, and it involves the phenomenon of upthrust here. So it says that a solid cube is floating in equilibrium in liquid mercury. So this is the solid cube. It is floating in mercury like this. The cube is made of iron, so this is made of iron, and the liquid is mercury. The cube floats with 42% of its volume. So 42% of its volume. So this volume is 42%. So this is 42% above the surface of mercury. What is the density of the mercury? So if it is 42% above this, then the percent that down should be below the surface should be 100 minus 42 is equal to should be 58%. So 58% should be immersed. This should be immersed. So that means that we have the volume of immersed portion by total volume of the solid should be equal to 58% by 100. Let us say it's equal to 0.58. So volume of immersed person by the whole volume is equal to this much. Now if this thing is floating, what we must have is the weight of a solid should be equal to weight of liquid displaced. Weight of solid should be equal to weight of liquid displaced. So displaced means when the solid comes like this, the liquid displaced should be like this, all over, all around, like this. So we must have mass of solid into G should be equal to weight of liquid, mass of liquid displaced into G and G goes. So this mass will change to rho of solid into volume of solid equal to rho of liquid into volume of liquid displaced. Now the volume of liquid displaced is equal to the volume of this immersed portion, because only this volume will displace liquid. So volume of liquid displaced should be equal to volume of the immersed portion. So this becomes rho L then volume of immersed portion. So that means therefore rho S by rho L is equal to volume of immersed portion by the total volume Vs, and that's equal to 0.58. So now we have to find the density of mercury. So we have to find this rho L. So we must have rho L should be equal to rho S by 0.58. Rho S is equal to 7900, which is iron, by 0.58. So when I do the calculations, it will be equal to, so it is okay, so 7900 divided 0.5 is equal to 136 something. So it is 13,600 something like this. So when we round it off, the nearest value here is, it is 14,000. So it is 14,000 kg per meter cube. So this should be the correct answer. Now this question can be dealt with by some another technique also. Since it says mercury, it is better if we know the data for the density of mercury. It is better if we know the data for the density of mercury. And the density of mercury is, it is stated as a 13.6 gram per cm cube, and that's equal to 13600 kg per meter cube, and the nearest value is this. So if you remember this data, we can avoid this whole process, because density of mercury should be same or similar everywhere, whether we know the process or not. So choice number C is the correct choice for this question.